Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass. Move along, move along. Come inside.
Hello and welcome. I'm Brad Kuvan, Editorial Director of MetalForming Media at the Precision Metal Forming Association. And on behalf of our entire team here, welcome to another episode in our ongoing Metal Forming Live series of broadcasts. Today's episode is a shop floor edition of Metal Forming Live, where we present use cases demonstrating how metal formers and fabricators are leveraging new state-of-the-art technology to improve their operational excellence. So today, we're specifically focusing and addressing how automation technology can help metal formers and fabricators drive efficiency and productivity gains, especially in light of the workforce challenges that we're all facing today. So I'm joined today on this expert panel by the other members of our editorial team, as well as representatives from two manufacturing companies, Pennant Inc. and Argon Industries. So we'll take just a brief moment now to have everyone introduce themselves on the panel, and then we'll launch into the program. So we'll start with Chris to my right here.
Thank you. I'm Chris Eifel, the president of Pennant. We are a premier manufacturer of metal stampings, roll forming, welding, decorating, and assembly. I look forward to sharing with you our automation journey during our discussions today. Thank you for joining.
Good afternoon. I'm Greg Clement, president and owner of Argon Industries. We are a contract manufacturer for sheet metal components in Milwaukee, Wisconsin. We have about 130 employees and do most of our work for all OEMs.
I'm Luke Kren, senior editor with MetalForming magazine.
And I'm Kate Bachman, also senior editor with MetalForming magazine.
And last but not least, joining us online today is Nick from Pennant. Nick, go ahead and please tell us about yourself a little bit.
I am Nick Laney. I am the Director of Operations for Pennant.
Great. So thanks everyone for joining us on the panel. And of course, thanks to all of you for joining us online today. Remember that we want these sessions to be interactive, and we want all of you online to join in the discussion. So, these guys are here to share their stories with you and in their automation journeys. Please feel free to ask them questions throughout the session today. You'll do that using the Q&A panel, which is located on the bottom of your Zoom screen. So without further ado, I'll turn things over to Lou, who's going to introduce our first case study with Argon Industries. Lou?
Thanks, Brad. Argon Industries, through Greg Clement, its owner and founder, was formed in 2002 with 4 employees and 3 fabricating machines. The Milwaukee, Wisconsin company has since invested substantially in production and automation technology. In 2013, after years of adding fabrication equipment, including laser cutting machines and press brakes, Argon Industries moved into its current 128,000 square foot facility on 14 acres, which allowed the company to consolidate 2 separate operations under one roof. Since 2018, Argon Industries has invested more than $8.5 million in state-of-the-art fabrication equipment and related automation, as well as quality technology and software. The hall includes turret punch presses and laser cutting machines equipped with load-unload automation, robotic welding equipment, a panel bending machine, press brakes with robotic tending, fastener insertion automation, and most recently, a fully automated robotic bending cell. And with that in mind, I reintroduce Greg from Argon Industries. And Greg, can you tell us a little bit more about your company, maybe materials used, products made, industries served?
Yeah, so we manufacture anything within stainless steel, aluminum, galvanized, galvannealed, high-strength steels, and hot roll. Most of the equipment is either enclosures or some type of sheet metal housing that would have electronics or large machines that actually go on semi trucks.
Okay. And, with the topic today, automation, obviously you've made a huge push into automation, and we have some video that kind of provides an overview. So if we could roll that video, and if you could take us through with some of that
Sure.
automation?
Sure. So in 2018, we replaced all our manual turrets where you had one individual operating the machine, loading and unloading the machine, the materials, and replaced them with fully automated load and unload towers. This tower that you have right here is 8 shelf storage. You can run this thing, the machine lights out, and it will automatically take the sheet off that's been cut and load the machine, the raw sheet onto the machine. And this is an 11-second process, whereas you used to have an individual, again, sliding the material 5x10 sheet, which is not safe. We had a lot of times where people would get cuts, and now we don't have any of that anymore. And we can run the machine lights out and just put the materials that are cut back into the tower.
And if we can move a little forward here to the press brake automation to see where these parts made here actually end up.
So this is the latest new automated equipment that we brought in. It's a True Bend Cell, fully automated tool changer, robotic. And what we're doing is we're forming this enclosure that just came off the punch. The robot can hold 300 pounds. So a lot of times in operating a press brake, if you have something heavy, you have 2 guys operating the machine and kind of coordinating the bending of it. Here, we don't have that issue anymore. The machine will pick up that part, form it all up, and then set it down on the skid. It's even programmed to stack the parts a certain way.
And you know, a lot of moving operations here, but still, you're able to, you know, run a lot of different jobs on here.
Yeah, we're looking at over 200 jobs that we're going to be running on that machine.
I think that probably speaks to the relative ease of setup and job change and everything else.
Yeah, the programming is easy. The main manual intervention is going in and loading and unloading the machine.
Mhm.
And the cycle times on the machine are similar to if a manual person was doing it. But again, we do thousands and thousands of these, so fatigue is always an issue. And with this machine, we don't have anybody that's, you know, getting stressed.
Goes to the complete cycle there.
We also have automation of a cobot on a press brake. This was the second one in the United States. It was very difficult to marry a cobot to a press brake based on the payload of the cobot, but now the payload on cobots are much higher, and we're able to utilize those. The good thing about the cobot on the press brake is you can see the parts. There's a lot of tedious forming, a lot of hand manipulation that our employees now don't have to worry about, and we can do a lot of these higher volume, smaller parts on this machine. This is the enclosure that we're welding on the robot. It's aluminum. We've had robots in our company since 2004. So we've been doing a lot of robotic welding over the years with AWS D1.1, D1.3. And again, this is a lot of repeatable, constant work that you don't have a manual welder getting fatigued. This is another robot where we're doing a rotary weld. But we have 7 robots in the company, welding robots. And this is a 2-headed robot with a Ferris wheel type turning system. And again, not only is this throughput, but on this piece right here that we're welding, there's 200 welds on it. So to do it manually would be difficult.
That's some great stuff, Greg.
Yeah.
In the intro, I had mentioned 2018, real push in automation. I think north of $8.5 million worth of automation going in. And you hinted at some of the reasons for that, safety and, repetitiveness, some of those types of things. But if you could kind of take me through your automation philosophy and how that all culminated in that 2018 push.
So we had a lot of pieces of equipment that were getting old. We're doing a lot of maintenance, and the throughput wasn't there. Customers were demanding higher throughput, higher volumes. And so the turrets were the first thing that I started replacing and looking at how do we get the throughput that the customer needs and without, again, fatiguing employees and doing it in a safe process. We went from 1 person per machine per shift to 1.5 people per shift running the machines. And the individuals are all, happy because it's a lot easier, less stressful on their bodies. And then we started moving into the press brake area and trying to find something that could help automate that, because trying to find press brake operators, skilled operators is really difficult right now. And we do a lot of training, we do a lot of cross training. So with the increase in throughput, we're about 200% faster in producing the parts off the turrets than we were with the older equipment. And then our laser cell had to be replaced. We went from CO2 lasers to fiber lasers, and that really increased our throughput as well.
And, increasing that throughput on the lasers, obviously that feeds the, the brake work and
Right.
everything else. So that has to, that has to get up to speed too, which explains, your cobot tended press brake. And also if you could talk a little bit about, we saw it in the video, that the kind of productivity gains from that new bending cell you have.
Yeah, the bending cell, every time you improve a certain automation somewhere, then you get a bottleneck somewhere else.
Yeah.
So you have to keep increasing that throughput as well. So with the bend cell, we're looking at equivalent manufacturing capabilities of 2 press brakes and 6 people.
Mhm.
So it's a constant, and especially as you get more high volume. And we're a one-stop shop. We have painting, so we're
Yeah.
getting more and more requirements to do higher volume, larger products.
And, you said you had robots, I think, since 2004,
Yeah.
robotic welding. So you've had a, front row seat to the advances in robots and that type of automation. Can you kind of tell me what you've seen in terms of, that evolution and what really, really powers it in your operation? Like, what is it? What are some of the evolving things you see in robotics that really make it a must-have for type of work you do?
Yeah, I think robotics are getting more affordable. I mean, the cobot industry now is getting much better, easier to program. You have less schooling that an individual has to go through for programming machines. They're more intuitive. I don't see AI yet in the robotics of it yet, but the robots just keep advancing every year. There's always somebody's launching a new product.
And, we did touch just a little bit on the programming. They're easier to program too, it seems, from what you had told me earlier.
Mhm.
So, and they play nice with the other equipment on those lines.
Right, right. Yeah. So it's easier to train too, and easier to cross-train people.
Mhm. And so what, if you could tell me the kind of expertise you had in-house to take best advantage of that automation. You talk a little bit about your team, obviously. All the automation in the world, it's only as good as the team that programs and runs it and takes care of it and everything else. So if you could kind of talk about the team that makes all this automation go at Argonne.
Yeah, so we have specific people that are doing programming for the turrets, programming for the press brakes, and programming for the robots. So the higher level programming skills are important, and understanding how the machines work and what you can and cannot do. So we have about 5 people that are involved in the overall operations of programming.
And I believe too that programming's offline.
Yes.
Could you talk about the relative advantages of offline programming?
Yeah, the whole key is you don't want the machine down.
Yeah.
So you want to program offline. Even with the ABB, we have Robot Studio, and you're programming 95% of the weldment offline. And then when you load the fixture, and you got to tweak a little bit, but it cuts the time down in setting up the machines.
And can you provide just a little more detail on moving from the turret press machines, from manual work to the automated processes, the loading and unloading, and what that's meant? I know you mentioned it briefly in the video, but could you kind of give me again a before and after from pre-automation to post-automation on those turret press?
Yeah, typically you would roll like a skid of material to the machine.
Yeah.
And hand load and unload, a pallet of material. With this machine, we don't have to do that at all. We just load the pallet into the machine, and it automatically loads and unloads the material, which has been advantage where we could run lights out. We have a long running job, and you can just load it up and run that full skid where we couldn't do that before.
Mhm.
And the throughput, like it's 200 times faster
Yeah.
than what we were doing before, which is, incredible.
Mhm. Oh, okay.
Yeah.
And just a little more about again, we touched on the new bend cell and the ability, I mean, it's not easy. It took, a while to get together and get everything going, but it looks like it's working great. But the relative ease of the programming and the setup that lets you an automatic tool change. And can you talk a little bit about those features that make that allow for 200 some jobs to be run on
Yeah.
that sophisticated automated?
Yeah, and so the real cool thing about the auto changer is, an employee's not handling these big dies and, putting them in the machine. The machine knows exactly where the dies have to go, even in a multi-stage setup. And then when you're done with that program, it'll take those tools out and put the new program tools in. So that handling, no one's pinching their fingers or anything like that.
Mhm.
And then just the machine operation itself, it'll go over there, inspect a certain feature, make sure they have the right part and the right component in the right direction in the machine, and then start running if it is correct. If it's not, it'll air out, and then an employee will come over. But the other beauty of it is once you have the machine running, like we're running that enclosure, they can walk away and go do some other things and go run a manual press brake, or maybe they'll move into a different department.
Mhm.
And while that machine's running, and we'll get optimization in several different departments.
And, seeing in the video and what we talked about, obviously you found so many applications for, automation, both, load, unload and robotic tending. And we're gonna see, similar things in a few minutes here with pen and ink. But, when do you have how do you go through that process, deciding when is automation a good idea for you? And, maybe in your crystal ball, what might be automated in the future in your operation?
So what we do is we go through a whole extensive process of getting part qualification for different vendors. What is the cycle time? What will be the cycle time with their equipment? And do an analysis of, okay, as I'm increasing throughput, how does that reduce my costs? And then deciding, we just did a ROI on another welding robot, and it was a 2-year payback for what we're doing manually welding that we could do robotically.
Oh, okay.
Yeah.
Well, that's it. Thank you very much for that.
Yeah.
Look at what you're doing, and I'm sure as we go along here in this discussion, we'll we'll have more back and forth about what's going on in Argonne, but, it's very impressive. I was up there and saw it and wrote about it. You know, it's great. It looks like great things to come too.
Yeah, thank you for having me. Yeah.
Hey, Greg, we do have a question from the audience. The question is, I guess really, and you mentioned how you've staffed up a little bit, but do you have did you add robot technicians to the staff? Have you added these robots?
They're not
And how many?
Programmers mainly.
Okay.
Yeah, not technicians. We have maintenance and then we have service agreements for the equipment.
Okay, okay. And so talk a little bit about more, how you set the robots up and change them over. Do you have a system in place for that? You've got some, a team of people that comes in for changeovers? How are you changing the robotic systems over? I think probably the
old to
welders
new?
we're talking about. Yeah, well, no, from
Oh,
a new program, from an old.
Yeah,
program to the next
basically
program.
for the robots, you have to take out the fixtures and put in new fixtures. We have plates that are all pinned and everything, so you can take them out, put them back in
Okay,
right away. And so that's an operator technically that's at the machine, running the machine.
then this is another question from the audience, and you always hear this when people talk about cobots, and supposedly they're inherently safe, right? Nobody's gonna get hurt by a cobot, but I think there's a little bit of maybe some false ideas with that. Do you have any safety devices?
Oh, yeah.
Enacted on the cobot? So talk a
We have
little
a
bit about the
scanner that
safety.
when you walk into a certain footage, the machine will slow down. You get even closer, and if you get too close, it shuts off. So
Okay.
you can't walk into that area at all.
Okay.
And the machine won't hit you. It doesn't have the force that a regular robot will have.
Right.
Yeah.
Okay, but there is some safety.
Oh, yeah,
devices
yeah, you
with
gotta have
the
safety.
cobots,
Yeah.
right?
OSHA wouldn't like that.
Yeah. Here are more questions. What type of quality inspection do you have in place for the metal forming and for the welding?
So we use a flat sheet scanner. It's called Inspect Vision, which is we cut the sheet in the turret, cut the sheet on the laser. We run over there, scan it, and it'll compare it to the DXF in like milliseconds. And then if there's an issue, it'll flag it with a color or something, and then we'll get a quality manager over there to look at it. We do first piece inspections for everything. We do PPAPs, all the inspections that are needed. And then in a running job, we do infrequency inspections.
And then you mentioned at some point lights out. How often are you running?
Every
Do you
day.
run the turret press and the press brake lights out, or just the
Not,
turret press?
yeah, the press brake can run lights out as well. Yeah, we're running every day. The
Really?
lasers run lights out. And so the turrets and the new press brake.
What was that like, getting the lights out, up and going? Did you have any?
You just gotta pick the right
Struggles with
products
that?
that, you don't have offsets, on a turret, or you don't have flip ups on the laser that you can keep running it and not crash it.
Could you predict some of that, or did
Oh,
you?
yeah, you can predict it.
Yeah?
You can tab it.
Okay.
So if you know that you're running lights out.
And the robotic welders, who's programming those? Or do you have like welders that program the robots?
Some are welders, some grew up in welding and learned programming, but yeah, they're mainly schooled. We send them to school based on the equipment that we have.
All right, great.
And I do have one more question regarding, especially on the, press brake, part handling, end of arm tooling. Obviously, you talked about the big cell there with, 200 plus jobs on it. You're probably running multiple jobs on the smaller trump brake with the cobot. What do you do in terms of end of arm tooling? And do you keep?
Yeah, we have.
Do you keep it stored nearby, and does that change?
So in the true bend cell, they're on a stands right
Okay,
there.
yeah.
But we do have to transfer some tooling out. We can use magnetics and we can use vacuum suction. So it just depends on the size of the part. We have some multi grippers that can expand, but some are very specific to the parts.
Okay. Do you build those in-house, or do you buy those on the outside?
So there's a certain part that you have to buy from the outside, but the rest we could build in-house. So the extruded aluminum, the grippers, you can buy all that stuff.
Okay, so
And-
there's maybe like a base you'll get, and then you could do all the build out
Yep.
in-house.
So for example, on the cobot, they were 3D printing the ends.
Okay.
All right, good. Thank you, Greg.
Yeah,
And so
thank you.
we'll come back after the next case study, and then we might have some more questions. So I'm going to turn things over now to the team from Pennant. Chris and Nick, tell us a little bit about what your company does and some of the automation investment you've made. And we do have a little video that shows some of that automation as well, but Chris.
Yeah, thank you, Brad. For over 56 years, Pennant has developed a rich heritage of metal forming. We established business in 1969 in our current facility in Sabina, Ohio, about 100,000 square feet. Over the years, we've grown both organically as well as through acquisition to now include 4 facilities, 3 in Ohio, 1 in Tennessee, and with our corporate offices in Columbus, Ohio. We have over 30 stamping presses and over 25 roll form lines. We stamp up to 800 tons, and we roll form off of 3.5-inch diameter roll form mills, which can do 3/8 thick material. We're here to talk about automation. We're early in the infancy stage of our automation plan. Our goal originally when we started automation was to be able to improve upon our manufacturing efficiencies through CI events. And now we've matured to the point that we use that data that we've gained not only to improve our current operations, but also to be more productive with new quotes to make sure that we're efficient. And for us, the benefit of the cobot, cobot's a collaborative robot, so it has some limitations that maybe a full scale robot may not be able to offer from a movement standpoint, a weight carrying standpoint. But for us, it's to supplement our workforce. And in the difficult times we have in trying to find labor, it allows us to redeploy human assets into other areas, which may need more, have more important needs to be able to check versus routine tasks such as packaging, welding, et cetera, and moving around. It also reduces fatigue and it makes us be more efficient overall as we work towards engaging and developing our workforce. So I look forward to sharing the video, and Nick is our operations director, and Nick will share the highlights of the video with you.
And I think before we started, Drew, what we're going to see is, so you've got how many cobots?
We operate now about 10 cobots total.
10 cobots doing packaging on roll forming lines as well as
Yeah.
welding.
Very good question. Yeah, we do it. We do packaging on roll forming lines. We also integrate with vision systems to make sure that we have part presence and part length from a prox switch standpoint. We then use it to package, and then we also do maneuvering for our robotic welding or our welding cells for projection welding or spot welding.
And then we also included, you'll see in the video, I think it's automation. It's not cobots, but you've automated your lubrications setup for four
Yeah, and
presses,
that's a very
right?
good question. In that CI process, we've done the analysis of how we get stamping lubes and products to our stamping facility or the stamping press, whether it's stamping lube, a quick draw, or any kind of draw lubricants. So we've automated that structure as well.
With a bulk tank and a distribution
Bulk
system.
tank and distribution.
So that's in the video.
Correct.
All right, so Nick, you're gonna describe what we're seeing in the video here, right?
All righty.
All right, here we go.
What we're seeing here is you're seeing the robot or the cobot unload the line, going from the line directly into the finished packaging tote. These sensors here are two sensors. One is a part length sensor. One is a part presence sensor that tells the cobot that the part is there. This one here actually is just reading the length, ensuring that the cobot knows that it is a good part. One good thing about the cobots also is when it stacks in here, it don't just stack in one place. It'll pick a line from the front to the back of that tote and actually disperse it accordingly. This here is our bulk lube system or lube tank. This here's our pumping system. This pumping system, mixes the lube and pumps it to 4 different presses. And during that operation, as it's pumping to the presses, we tie in with press controls, which will fire off the lube for the tools that, the location of the tool or the part that needs the stamping lube. This one here, you'll see again where the cobot is used to pick up the part and put it in the finished good tote. Some of these vision systems also can identify notches or holes in the part to ensure that they are there also. Again, this is going into the finished box. And if you look at this, you'll see that it's not all just bulked into one pile. It's actually mixed across. This cobot here is loading our projection welder. It is orienting the part accordingly as it comes down to the conveyor, from the conveyor. Then you'll see the weld projections be put on. And then it will kick it out automatically onto the table on the other side. We did mention a little bit about the cobot. The cobots are safe. This particular cobot, if you was to be in its way or if it was to bump something, it would shut off. Here again, you're seeing these vision system here is actually looking for some of them holes in that part right there. One thing, this cobot here, as unloading the line, you see it's unloading more than one part at a time, which is a good part for us to where you don't have one person back here just bulking up, just a layer of parts.
Good, thank you, Nick, appreciate that.
You're welcome.
You showed the vision system integrated with the offloading line there. Did you use vision to inspect the parts before the cobots, or is that something you added when you automated those?
It was not as effective as it, when we brought the cobots in, it actually made it, let's just say whole. It's more effective now with the cobot because you with the cobot understands if we're not seeing something, the cobot will stop, and then the line will automatically reject something if there is any kind of rejection or anything. So I think it just pretty much made it whole, if you would.
Did you have any issues at all, or talk about integrating the vision system to the automated setup? Is there any trick to getting that done?
No, that is one thing good about the cobots and, the vision systems that we use. Everything is, a couple things. One, everything is pretty much off the shelf from the suppliers, and two, everything handshakes very well with the cobot and the vision system. So even the press controls do too. So
You put in, what did you say, 10, 11 cobots, 10 cobots? I'm sure that the trick is making sure that those are maintained well and kept running at their optimum, operating condition. Do you have a structured maintenance plan in place to keep those cobots up and running?
Yes, there is definitely a PM program for the robots, as well as all of our other equipment in our facilities. The robots are maintained by our maintenance department and our engineering department if need be. But yes, there's definitely maintenance programs for them.
Same question that we asked Greg here. In terms of programmers and technicians, did you have to add any specific talent to your team to move into this automation realm?
No, almost identical to Greg. There is, we did send our engineers out for training. We did not have to add any programmers or anything like that. So that is a strictly an engineering feature. Our maintenance department they do have knowledge of the robots, and if needed be, they could do almost identical what our maintenance department can or our engineering department can.
Are those lines dedicated? I know I was up there and I can't remember what you guys told me, but are those lines dedicated to the same product repeatedly, or do you have to change them over occasionally?
Dedicated, they can't be changed over, but dedicated.
Yeah, absolutely. They are dedicated, but if we need to move one around or something, we are able to move it around and go rather quickly on the situation. So.
And I know you had talked about, how you selected that area of the shop to be automated, and what you really wanted to do, I think, was move some of your technicians, your operators into the press room, right, to make sure the press room was well staffed.
Yeah, with the difficulty finding direct labor, we wanted to make sure we had the right staffing levels in other areas of the plant, which were less routine parts. We talked through cobots and robots. Cobots are collaborative. And Nick had mentioned it during the video. However, we had one application that we had multiple parts that we unloaded. When we looked at it from a CI or cost improvement standpoint, what we didn't want was the cobot to be the constraint in the manufacturing process because it's a lot less expensive than what a press or a roll form line would be. So Nick and the team looked at multiple unloading stations. So you may not see a single pick and place, but you may see a multiple pick and place so that the cobot itself doesn't become the constraint. Because when you're evaluating cobots, cobots are easy to program. They have some weight limitations versus a full-fledged robot. But again, our overall process was to make sure we had an efficient process with redeployment of labor and making sure that we had those efficiencies by checking and reducing fatigue.
For both of you, was there any issues with your workforce bringing in all this automation? Did they welcome the opportunity to maybe do less manual and
Yeah,
more
in the
value added?
In the beginning, people were nervous, they're gonna lose their job, and rumors spread on the shop floor
Sure.
very fast.
Sure.
And once they realized the technology that we're bringing in and how it was gonna be used, and that no one was gonna lose their job, and we're gonna cross-train everyone, that everyone calmed down, and now they're like, what you getting next? So,
Yeah,
yeah.
okay.
Yeah, from Pennant's standpoint, we didn't remove any operators. They were redeployed into other areas. So pretty well welcomed. They've integrated to have the cobot help them in their process.
Right. Now you want, people are probably volunteering to work with the robots.
Yeah,
Oh, yeah.
exactly.
Very good. Question from the folks online, and please go ahead and ask these guys questions using that Q&A panel. Are any of you gathering data off of the floor from your processes, Internet of Things type remote data gathering? And if so, are you using that, or if not, are you looking into that?
From Pennant's standpoint, we don't. Everything's shop floor reporting, real-time shop floor reporting, nothing remote. But we put KPIs in place to make sure we're managing safety, people, processes, delivery, and financial performance of the organization. So it's real time through an ERP system, but nothing remote. Yours is much more remote than ours could be.
Well, yeah,
Lights out.
we're looking at right now machine utilization and adding that component to the machine so that
Okay.
we're managing the machine uptime, arc time, and things of that nature. We just implemented Power BI to track all this information, gather all this information through our ERP system because everything's real time is what we're punching in as that. So Power BI, it's a Microsoft product.
Oh, okay.
Yeah.
So you just implemented it?
Yes. Yeah.
Cool. Okay.
And we look at, uptime KPIs from an efficiency standpoint, both from a labor absorption as well as throughput. So, but again, nothing.
Any other measures you guys can share in terms of improved quality, productivity, safety from the automation? I know, Greg, you had mentioned you significantly grown without having to add to the.
Yeah,
to the
we've
labor.
over doubled our sales and have the same head count. They're just more skilled now, and we went several years where we had tons of overtime. We were working people to death and trying to keep up with the customers. And now we have a huge, real good core base of employees that we're able to do better with them, give them higher wages and better benefits because we're not adding a bunch of people to do some of the work that we can automate.
Any other KPIs that come to mind? You both talked about improved safety. I don't know if you actually been able to quantify less incident, lost time, or.
We've had definitely less incidents.
Yeah,
for sure. Yeah.
You're dealing with sheet metal that's got some
Very sharp.
edges,
Yeah.
right? And then all the manual labor involved in
Go with it. Right,
packaging,
packaging.
right? So the loaded question of the hour, right? Which was really more important as you evaluated automation? Was it, you used the term labor replacement, but in your case, you couldn't find workers.
Couldn't
and I
find
know
workers
that's
in those
still an
areas.
issue. Or is it increasing productivity? It's probably a combination of both, right?
Yeah, I'd say the answer is yes.
Right.
Really both is that want to make sure that we're able to continue to improve upon our efficiencies. At one point, our efficiencies were well below standard. Now each plant's above 85% efficiency, which is a combination of what the KPIs we put internally to be better. But it's really both. We need to be efficient in today's market to make sure that we're able to grow our business and stay profitable where we are right now, and to make sure that we can grow business, but also to make sure we're able to operate with the shortage of labor and other constraints that we may have in the manufacturing process. So really both.
Good questions coming in from the crowd. What What about your insurance premiums? Did you notice a difference in insurance with automation and improved safety perhaps? And
Workman's
Does
comp,
that
we have a
affect?
better workman's comp rate for
Yeah,
sure.
okay.
But the insurance is, going up no matter what right now, so nothing changed because of the automation.
Okay,
Yeah, we agree with that as well with us.
interesting question.
Yeah, very,
Yeah.
very good.
In terms of results, I know we did an article on the loop system, but I don't know if Nick or Chris, if can you comment on what that automated loop delivery system did for your operations? Yeah, you
One,
want to handle that one? Yeah.
yeah, one thing it did is it really reduced our downtime. To where our operators not going to collect lube and fill their tank, their lube tank that's on the press equipment. Another thing it did is it has uh, overall reduced the waste of the lube, which I think is going to be, as at the end of the day is going to be a cost savings for the lube anyway. So
And I think you also talked, if I remember correctly, about the consistency of the mix, right? Making sure that you have
correct.
the same.
Correct. The automated lube system, the way it mixes, it comes out of the bulk tank and mixes with the water. We use a mixer that you can adjust to get the right mixture you want. So yes. Um,
And then I know when we were talking earlier today, Nick, you mentioned with the cobots, just the combination of versatility and how simple they are to work with. And you said something about reduced footprint too, right? Which makes them easier to fit into your production operations.
that is correct. You take a full blown robot, you have a large footprint, but with these cobots, the size of the cobots, they fit really well in tight areas when you have a smaller footprint. So
Actually, to piggyback on that, about the footprint, any advice from, Pennant or Argonne, people considering automation, about your floor layout, your plant floor layout, your work routing on the shop floor, what did you have to consider in bringing in automation in terms of what your facility layout in your room? And are there areas that you wish that you had thought about earlier in the process or had planned for in automation, maybe as you went along? If anyone has any thoughts on that?
Yeah, it's our facilities are existing. We have one new facility in Lebanon, Tennessee, we built brand new, so we have the room and we have the benefit of laying that out the way that you would. But as Nick mentioned, from a space standpoint, when you have an existing facility that you're tight in space to begin with, we may have done a different structure if we were starting fresh with a new facility, a greenfield facility versus where we are right now. But the cobots can fit in tight spaces. They're easily maintained. They don't need to have cages or protective mechanisms like a full-fledged robot usually does. So we may have made a different decision from a new facility, but with the existing facility, the cobots were the best source from a cost and economic standpoint, and throughput and space standpoint. Training as well.
Yeah, we have a plant layout, and when each piece of new automation that came in, like the bend cell's huge. So that took up a lot of space. So we had to move equipment around and reorganize the shop floor to make sure that we had the correct workflow going to the robot and then coming out of the robot.
I imagine things like utility routing and things like that, you had to make sure you had the power getting to it, and any compressed air or
Yep,
lube lines or whatever. that might be.
foundation, yeah, all kinds of things, yeah.
And I believe, for cobots, you probably don't need as much rigid infrastructure to power those up and keep them going.
Yeah, we talked, Greg's process is impressive where he has the walking beam during that forming process. You wouldn't put a cobot, we joked earlier, you wouldn't put a cobot on a walking beam in order to be able to move it. But there are cases where that would benefit us. And if we had the room, we may do that as well with a more fledged integrated robot versus the cobots. Very good point.
I just got a couple questions of both of you, Craig and Chris. In terms of the maintenance, what break that down for me. What types of maintenance are required for the robots and cobots?
For the robots, it's a lot of lubing, a lot of making sure that the gears have the correct lube in them. Cleaning, you have to clean the machines. There's a lot of smoke, a lot of dust coming out of the machines. So there's a PM program for each machine. Salvanini has a different one. Trump has a different one. All the machines, they all have different schedules and what you got to do. But it's a high piece of accurate equipment, so you got to treat it like that. I mean, you wouldn't let a Ferrari go by and not change the oil on it. So you got to make sure that it's always we're following the PM programs.
In addition to lubrication, are there consumables that have to be replaced?
Yeah, welding, there's always consumables, tips, liners, things of that nature. In the press brake area, there's really not consumables other than the grippers. Those kind of wear out at times.
I'd say the same thing as Greg, end of arm tooling is very important to make sure it's maintained. The lubrication, bearings, maneuver points or movement points on the system as well, because Nick and the team also uses vision systems for part censoring, make sure the lenses and the lighting systems, the LED systems are appropriate. Nick, feel free to add anything in here from a maintenance standpoint, but
Yeah.
No outstanding maintenance items than what you'd normally do from good practices in your equipment. So.
Are you using a maintenance management system to manage these automation devices, or just something that the equipment manufacturer maybe provided you with?
Yeah, so we have both. So we have a Unipoint system that we log everything and do the maintenance and what we actually maintain or replace or fix. And then in certain machines right now, we have a PM system that's already programmed in the machine, and it'll tell you need to do this now.
Okay.
And based on hours and.
We use a software system, Dude Solutions, that mirrors what the manufacturer's recommendations are, as well as our own experiences to be able to maintenance our machines.
So as you add automation, you just put that into the
Put that in there.
system.
Yeah.
One of the things you always hear shops discuss, or consultants as well, when you invest in automation projects, is do you bring in an integrator to help you, or do you try to do it yourself? And I've heard different levels of success with each strategy, right? But did you guys use an integrator? Did you kind of figure it out on your own?
Yeah, so in a lot of the pieces of equipment we buy, it's fully integrated, and they come in and do the setups and get it up and running. So we haven't done integration ourselves yet, but almost all the equipment is installed by the company that we purchased the material or the equipment.
Right. Okay. And how about you guys?
We use initial integrator. We still use integrators if something's more difficult, but we have two in-house manufacturing engineers that can do a lot of the program, as well as our maintenance staff.
Do you want to share who your integrator was, or do you want to keep that to yourself?
Keep that to ourselves.
Okay. I'm sure that was going to be the next question.
Yeah, right.
So in terms of locating your cobots then, Nick and Chris, did you do some type of a study or use software to figure out where best to put all this equipment? How did you actually lay out those lines?
Yeah, no, good process, good question. So we use value stream mapping. So we do a SIPOC and a value stream map to make sure we understand how the process flow is for the product, to make sure that we can even justify making the investment in the beginning.
Okay.
We have a relatively tight line for justification of our CapEx, and that's a 1-year payback. So in addition to looking at the efficiency and all those other intrinsic values of adding automation, we also make sure it has the appropriate payback as well to be able to yield it as well. But process mapping, flow, SIPOC, and process improvement to be able to do that. And then, as Nick stated, on one job we have right now, we built that in. As we gain knowledge, we gain information relative to the automation processes, we build that into our quotes in the future to make sure that we're efficient and effective in those quotes going forward.
1-year payback. That's
1-year payback.
nice.
Yeah.
Yeah,
Is
that's
there
very
a
good.
volume associated with that payback?
That's
Do you have
one
a
nice.
certain number of parts?
One thing nice about the cobots is, we discussed, cobots about $30,000, much more economical than what a $75,000 plus fully integrated robot is, in addition to the room. So the payback is a lot improved in a lot of cases. And again, the goal is not to reduce labor. The goal is to improve efficiency and redeploy labor. But we have a cost benefit analysis that we use to do the investment as we do the SIPOC and the value stream mapping on how we make sure that we can justify that investment, because there are some cases, let's face it, you can't justify the investment even at a $30,000 cobot to make it make sense. But, you know, from a volume standpoint, we run multi-million volumes of parts, but we typically are in the medium standpoint. You know, just as a gut feel, usually around that 10,000 unit standpoint, you can start justifying some automation and equipment when you get to that kind of volume. Because the other piece is we run a lot of parts that may be one family, but there may be 25 different SKUs with different hole patterns or different configurations. And those may become at times difficult to be able to justify investment with that much, uncertainty or that much mix in the process.
Are you correct? Is there a volume associated with your ROI?
It sometimes is, sometimes it isn't. For our Salvanini, you know, there's no setup. So I can run onesie, twosie, switch parts, I can run kits and be productive and get it to a paint line. Or we could do, you know, thousands and thousands of pieces. So we look at more what is the cycle time on the machine, am I improving the throughput? And then what can we put on there that makes sense? But we've run even in the bend cell where we've run 25 pieces.
So it's really not part volume so much as cycle time.
Cycle time,
Improvement.
yeah. And safety.
Good questions. Couple more here, and you guys keep them coming. We've got some more time, but Greg, you mentioned a 2-year payback, I think, on the robotic welding, so right, the ROI on that.
On the bend cell.
On the bend cell, okay. So when was that the press brake cell or the
Yeah,
bending?
press brake.
Yeah. So for a company of your size, the question is, when you're moving from a standard press brake to an automated cell, is that 2-year payback about right? Did you think that was like
Yeah.
ahead of what you thought you were gonna get, or was that right on?
It was just installed, so I haven't realized it yet, but yes, that's what we're planning on.
Okay.
Plus, I don't have to replace my older machines. So the value is machines that I have that I won't be able to find parts for anymore. And this new cell will take over those machines and then increase the throughput, so.
Okay. Future plans for automation?
I'm looking at a vision system that can inspect welds. So we're going through the quote process right now to find an economical way to inspect the welds. There's not a lot of welding vision systems out there, so we're looking at that now. I have 3 people that inspect welds, and if I can reduce that, the fatigue, just moving the part, everything, your eyes, that would be a huge advantage.
Yeah, we're hearing about continuous improvement in that type of technology, right? With artificial intelligence now being able to input photographs of good welds, and the AI system or the vision system can automatically run through those photos, compare your images, as long as it's just visual inspection.
Right. Yeah, it won't be X-ray.
Yeah. How about you guys, future plans?
Yeah, from Pennant standpoint, as appropriate, we started business in Sabine, Ohio, and that's where we started our automation evaluation as well. We've integrated vision systems into other Pennant facilities, however, not the cobot structure. So we'll carry those across the organization to make sure that we're efficient. Nick was recently promoted to Director of Operations over all of our plants, so he'll be responsible for integrating that automation structure. And we'll get more detailed and more integrated in maybe larger robots, bigger vision systems as we learn more and as we grow the technology. So definitely it's something we need to keep in mind in the future to make sure that we're competitive, efficient, competitive, and that we're taking care of our workers.
So the question from the audience for both you and for Nick as well. Starting down an automation path, and about everybody has already done that or is looking to do it, right? What was the biggest mistake that you would advise others to avoid? Not that you made it necessarily, but if you were to make a mistake, what would be the one to avoid?
When I installed the paint line, it's fully conveyorized, and we have auto guns and all that. Just understanding the capabilities of the machine, of the paint line, and I miscalculated the complexity of installing that powder coat line. It was very complex. There's a lot of moving parts that go into it, and how to save the powder and reclaim the powder, and that was the first thing that I kind of missed on. It took a little longer to get the payback.
So you had a powder coat line?
No, I never had a
This
powder
was all
coat line.
new.
I outsourced to 5 different powder coaters and wanted to bring that in-house and take control of it.
I see.
And, yeah.
You had a whole new respect for.
Yeah, I
your
do.
suppliers,
Yeah,
right?
absolutely.
Very good. Okay.
And, from our standpoint, we share, more information, get information, make sure that you understand and try to plan to not just integrate the automation for the next year, but the next 10 years, so that you know how you're going to grow. Shared a story over dinner where we had a situation that one of our cobots in line were pulled offline because the plant leader at that point said, gosh, I don't want the cobot being the constraint in the manufacturing process. So rather than look at ways to remove that constraint or that bottleneck by increasing the amount of parts that the cobot picked up, he felt it was best to pull it offline and put direct labor back into the process to speed up the rate. So, and Nick, I want your input as well as our operations leader, but it's make sure you have enough data and make sure that you plan out in the future. You can never have enough data and you can never make all the right decisions, but have as much information as you can. Do a long-term plan on it and make sure that the group is educated, your team is educated on the benefits of that and how you integrate it, so that you don't run into those, well, gosh, I can run it faster with a person, just take that robot off of cobot.
Yeah, absolutely. And another thing is, I think just as important is, don't just reach out to one person or one company, one robotic company. There is numerous of them out there, and by all means, call more than one in, call 2 or 3 of them in. Lay the scope out, make sure everybody understands the scope, and then understand where they're taking you with the scope that you're looking for. I think the more eyes on whatever your system is that you're trying to accomplish, the more you're going to understand it, and then the better you understand it, the more you're going to be able to tell your automation team to, this is what I want. Have a good understanding of it. I think Greg and Chris both said, we having a good understanding of it ourselves will help everybody understand from your team to the automation team. So
Yeah.
Very good, very Nick, thank you.
Yeah, Greg, you even talked about doing some time studies, right, with
Yeah.
your suppliers before you picked one?
Yeah, we went through multiple companies to get time studies and just look how the equipment works, how we have to work with the equipment, and the advantages and disadvantages of them. Yeah.
So did you give them part programs
Oh,
or sheet
yeah.
metal, and they were actually?
Yeah, we give them solid models of all the parts that we wanted to put on the machine,
Okay,
and they did analysis on it. Some parts you could do on certain machines, some parts you couldn't.
yeah, that's good due
Very
diligence.
nice.
Yeah.
That's good.
And I might add one other thing. Maybe keep your integrators, your automation suppliers close by, because it's, as Brad mentioned, those heading down the road of automation, it's a road. It's not a dead end.
Yeah.
It's a commitment.
You automate one thing, as was mentioned earlier, one thing is automated, that opens, that there's a bottleneck somewhere else.
Yep.
And it seems, and you always have to stay ahead, find that where the bottleneck will be, and, your integrators, suppliers, that kind of expertise can really help, and as you put in automation, they'll say, hey, well, maybe you ought to consider this down the line. Or,
Yeah.
because they've seen a lot of it, so, they're probably good resources.
Well, speaking of journeys, so can we talk about the journey? About how long is that journey to install and implement automation? Various different cases.
For me, it's it could be really quick, because some of these cells are just pre-built cells. You bring them in on a skid in a Ford truck and put it in place, wire it, and go.
Which ones?
A lot of the robotic welding that I
Okay.
have, they were all existing, or they build certain cells. So we're not actually doing the integration of the robots. The cobot took, maybe 2 weeks to install.
Okay.
The turrets took a little longer because you got a lot of alignment issues with the equipment. But within a month or two, you're up and running.
Do you find it to be about the same?
Yeah, that's one of the nice things about the cobots being so flexible and light. You can move those pretty quickly. If we have them on site that we can integrate, it's usually within a matter of days from an integration standpoint. Much less time to automate and get a PPAP part on a cobot than would be on an integrated robots.
Yeah, and the hardest part for us was for the manufacturer to deliver.
Yeah, yeah.
So the bend cell was, almost 3 years before I got it up and running and got it installed. There's 6 months, 9 months waits on getting equipment right now.
I see.
I want to go back to, you talked about the cobot not being the bottleneck process. I even noticed in your video too, Greg, that it doesn't look that in all cases that you're making that many more parts per hour, or parts per minute. So the difference between, what I'm getting at is the difference between production rate and overall production, right? So you don't have breaks, you don't have sick, you're running lights out in some cases. What are your thoughts on what are your thoughts on that in terms of justification, right? So you may not be running faster. In some cases, you might actually be running slower, but your overall production capacity at the end of the shift is higher. So when you go to do the justification, I'm sure you have to consider that, right? It's not just speed.
Absolutely,
right?
yeah.
You know, you do, while you're not intended to reduce labor, you can take labor off the line. We maybe run 2 laborers on a roll form line that has a pre-pierce, pre-notch roll form and then cut off. You may be able to reduce it to 1 laborer, move that. So you do have a labor savings, but you're at an uptime benefit. You can run the machine at its pace. At the perfect world, you run it at its pace and not be constrained by other elements of the process or other automations of the process. So you do get a labor savings, then you get an uptime savings as well.
Right.
And the quality piece of it as well when you integrate the vision systems. So you don't need to take it offline or don't need to stop the line in order to be able to take apart and check it. Even though there are cases where we do that, but you keep the line running, pull the part off while the line's running to be able to validate and quarantine your parts.
And you're getting greater consistency
Correct.
as compared to manual.
And repeatability in the process.
Yeah, for sure. If you're doing all that robotic welding, right, you need good fit up coming off your press.
Yeah,
brakes,
exactly.
bending machines, right? Have you noticed an
Oh, yeah,
increase in
much
quality
better
from the press brakes?
tolerances. We have to produce it.
What advice do you have? You guys are the expert. What advice do you have for metal fabricators who don't have automation experience today? They don't have it on their staff. Maybe you work with an integrator or what have you, but who do want to get started with automation and robots? What would you advise?
For me, the first thing, go to FabTech. Go look at all the manufacturers that are out there around the world and see what's out there and see, Automate is a good show too. But you can see exactly what different equipment manufacturers are building and integrating right now. I mean, that would be the first place to start.
Great.
Educate yourselves.
Educate yourselves.
Educate yourselves.
Like events like this.
Yep.
And we'll be at Automate in a couple weeks, and of course, PMA is a co-producer of the
Yeah.
FabTech show, so appreciate the
Yeah,
plug
very
on,
good.
plug on FabTech. Questions from you guys? I think we're.
I would just be interested in what operation would you say would be the first one you would go to automate?
Wow, I mean, for me, it just depends on the parts that we're doing, the opportunities that we have. And just looking at that and then equipment, do you have antiquated equipment? What do you need to do to be competitive?
So in your case, I think you said that your equipment was getting obsolete.
Yeah.
So that was a natural, before we replace it, instead of just replacing with something of the same,
Right.
go to automation. How about you, Chris?
Routine tasks, things that will play well towards a cobot because that's our first line of investment. So routine tasks that can reduce fatigue and to operator just maneuvering parts around. So that would be our first approach. The second piece is routine. Next step after routine tasks would be movement of parts for value-added operations such as welding, projection welding or whatever. Not that's what we're started at now. With Greg's operation, he's doing a lot more part movement and more integrated with robots, and may go there one day as we get bigger and bigger parts. Good question.
One last question for the panel regarding the workforce. We talked a lot about the safety issues, things like that, monotony, put personnel in more challenging roles. Maybe about reaching new employees and retaining employees, the importance of automation. We hear it a lot, about dirty, dingy environments, but automation you know, you have cool automation in there, new machines, new technology. It certainly attracts, I think, the younger people who are looking for work, and it certainly helps with retention. Can either of you speak to that, or even maybe community outreach that you do, like what kind of feedback you've heard from maybe people coming in to see your
Yeah, so
operations?
we try to work with the community in the different chambers. And then also I work with a local school, high school, Wisconsin Lutheran High School. And we bring the students in, we show them the equipment, we show them that it's, you know, this isn't blacksmith.
Yeah.
You know, these are fully automated machines, and I try to relate it to, you know, the laser cells, you know, 5 Ferraris, you know, and when they see that, they get excited, and they're like, well, yeah, I don't have to, you know, do all this dirty work, and I can actually be in charge of running that machine, and that really generates a lot of activity, a lot of excitement in kids in high school. I think we have to get into the grade schools as well to start talking about what we do and how we do it. Because the parents have been the biggest obstructor, because everyone's got to go to college. And no, we have guys making well over 6 figures in our company that have careers, raise families, and that's what we kind of promote.
Yeah, I'd say the same thing. The labor force is changing. So rather than from manual in both of our cases, so rather than bringing in operators that have manual labor, they're doing more checks and validations and improvements of the processes and monitoring the processes versus just manually moving parts around. And that should be more attractive to the direct labor workforce than what manual movement is.
One of those benefits that don't necessarily show up in the ROI, but
Right.
it's, you know, notice that.
All right, well, I don't think we have any more questions from the audience, so we'll wrap this up. I'll thank you guys for joining us. Nick, thank you for joining us online. Kate and Luke, great job.
Yeah, thank you for having us.
Yeah, and thanks everybody online for joining us today. Please join us later this summer for our 3-part Metal Forming Live series. We're going to talk about 3 different technologies. The first one will be on in-die technologies. Then we'll cover stamping of advanced steels. And then we'll get back to the topic of automation and do some best practices for automating the press room. So keep an eye on our website, metalformingmagazine.com, for more details. It starts at the end of June and goes into July. So again, thanks to all of you, and thanks to our great panel for being with us today.
Thank you.
Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass, move along.